Hi, I'm Bruck Syal. I'm a physicist at Lawrence Livermore National Laboratory, where I work on planetary defense research. Planetary defense, if you're not familiar, is the field of study focused on if an asteroid or comet were going to impact our Earth, what could we do to prevent it? And a lot of our work is focused on supercomputer simulations of how an asteroid would respond to various deflection techniques. A deflection is simply a small change in velocity that's delivered to the asteroid so then it misses the Earth. So you can think of that as, here's the asteroid, here's a spacecraft coming in. If we're using just a kinetic impact approach, the spacecraft, which is going quite fast, tens of kilometers per second typically, crashes into the asteroid and delivers its momentum, its mass times its velocity to the asteroid. And the asteroid weighs a lot more than the spacecraft, so it's going to give it a relatively small push, something on the order of a centimeter per second. A centimeter per second tends to be enough to miss the Earth if you have about 10 years warning time. Depends on the asteroid's orbit, but the bulk of the asteroid stays intact and they will then miss the Earth. But one of the most challenging aspects of planetary defense research is that we don't know the details of the asteroid's material properties ahead of the deflection attempt. And so today I've planned some impact experiments to demonstrate how different asteroid material properties can affect the outcome of a deflection. For our impact experiments, we'll be using two different target materials. The first on the left here is perlite. It's used in gardening a lot. Perlite's actually a volcanic glass that when it's heated up, a lot of water evaporates out of it and it puffs up, so it becomes very low density and fluffy. That means it has a high porosity. Porosity is a measure of the fluffiness, how much of the bulk space is taken up by voids. And so it's very high porosity, around 90%, and the bulk density is something like 0.2 grams per cubic centimeter. And if you're familiar with Dippin' Dots, this has a texture, structure kind of like that. So a lot of fun. Over here we have just regular old SiO2 sand. And sand, it also has porosity in it. Something with no porosity would look more like a crystalline rock.